Hi, let us have a quick understanding on Docker Swarm. Docker Swarm is a container orchestration where it manages the containers and provides scalability and availability. First, we need to have understanding why the need for an orchestration. Assume I'm going to have a Docker machine and I'm going to deploy containers within it. If it is in few numbers, I can somehow manage. And over a period of time, the number of containers will increase drastically, and managing these containers will become very difficult. As well as whenever I am upgrading the application or taking the node for maintenance, it's going to be even more difficult to provide high availability and scalability of the application. Nowadays, every application demands very high scalability and availability. For that, we need to have understanding on what is scalability and availability. Assume I do have a host and containers deployed within it. Let's assume it's the web server made of Nginx. The main purpose of having container is I can distribute the load across multiple machines. Assume I'm going to have 3 Nginx distributed using a load balancer. A load balancer could be another container or it could be a external load balancer. Now the load will get distributed across all these machines. If there is an increase in the load, what will happen? Few more containers will get added into the host or the another host, and the load will get balanced across all those containers. Now the load is distributed across multiple containers and I am serving all the applications. This is scalability, that is providing elasticity for the application and serve whenever there is a high demand in the load, as well as remove the containers when there are no load to the load balancer, so that I can reduce the cost and balance the load with the containers that is available. So this is about scalability, and availability is making sure the container is always available. So how I will be serving it? I may have n number of hosts distributed across different geographical locations, and the load will be distributed across these containers. If there is an issue with any host, that particular container will not be serving the request. Let's assume this particular host faced an issue and this particular container is not going to serve any request. So what will happen? The load balancer automatically route the request to the different host and it will try to start containers in other host and balance the load. So this is about availability. Availability, we can do it at the load balancer level or at the container level or even at the DNS level. That's going to be the task of the infrastructure team. Now, the availability and scalability is very well supported by the Docker Swarm. For this particular purpose, I am going to have a cluster. Now let us understand what a cluster is. Whenever I say a cluster, a group of hosts together makes a cluster. Let's assume I have 3 hosts and all these 3 hosts we call it as a worker machine, and it will have the capability to start n number of containers within them. Let's assume these are all the number of containers it can start with. And to manage these hosts, I need a master. So I will be having a master which will manage this specific host, which will manage this list of hosts. So I'm going to have a master worker architecture, and the Docker master will manage the workers. So I'm going to have a master and workers. And each host internally it will be having a Docker daemon so that it can manage the containers it is starting with. And within master, we will be having a scheduler and a Docker discovery service. So I'm going to have 2 important components. One is called scheduler, another one is discovery service. And any Docker client can communicate with this particular master and request saying, I want to deploy this particular application into the Docker Swarm. I will say I wanted to have an Nginx container which will have 3 replicas. So what will happen? 3 containers with Nginx will get started, and I can have a load balancer that could be another container, and load balancer can be configured to route the request to all these 3 different containers of Nginx. So the main advantage of Docker comes into picture over here. It can schedule the container wherever it is required. In case if this particular machine is entirely occupied and if there are no resources available, automatically the scheduler will identify which host can host the next container. Assume the Nginx web server is getting more load and it needs to scale up. Say a 4th container needs to get started. Automatically scheduler will identify which worker is having more space where it can serve another container, and automatically another container will get started and it will be mapped to the load balancer or to the discovery service. Here's where the scalability comes into picture. Now, with the same picture, let's discuss about the availability. Assume I wanted to deploy this particular application with the new version. Say I have the version 1.0 and I wanted to deploy the version 2.0 within it. For that purpose, there are different type of strategy available. What the container can do, it can deploy the version 2 with the same scale what it is required and map the load balancer to route the load to this newly deployed containers. That is one strategy. Or one after the other, it can replace the containers. Slowly, one after the other, it will be replacing. So this is the strategy how I am going to deploy. That would be taken care by the developers. But SWAMP supports all these different type of strategies where the end user will not feel this particular application is getting upgraded and there will not be any downtime. Without downtime, I will be in a position to make the application highly available, as well as even if any container goes down, automatically it's going to start another container in another machine or in the same machine, and always it retains that particular state, in the sense the required number of containers it will be maintaining. So as we discussed, it's going to provide the very high scalability and availability. Along with that, it's going to provide the rolling updates of the applications as well, and regularly it does the health check and maintains the life cycle of the application. When it comes to Docker Swarm, we need to have understanding on various terminologies like stack, services, task, how to manage the Swarm nodes, that is the master node, worker node, how to add new nodes, how to take the nodes for maintenance, as well as the networking within it. We need to have a good understanding. In this particular section, we are going to discuss each and every point, right from setting up our own Swarm cluster and deploying the sample application, verifying the scalability, availability, rolling updates, all that we are going to verify.